We will now begin chapter 2, which is called analytic geometry, and we will begin with finding the midpoint of a line segment. All right, the midpoint of a line segment is the point directly in the middle of two endpoints. So if I told you, let's say you have a point at A, which is down here, so that's at -8, 1. And then you have this other point B over here, which is at 6, 7. What we're looking for is to find that midpoint, that point that's somewhere in between. So if I just tap it here, okay, so what is the midpoint between A and B? Well, we can see our midpoint right here. The middle of the line is at -1, 4. Okay, we can see that. If you take a look at our rise over our run, so if I go all the way over, all the way up, sorry, not a straight line, but notice that this went between -8 and 60 and 6, which is 14 units. So half of 14 is 7. So if I go over 1, 2, 3, 4, 5, 6, 7, notice I get this right here. And same with our rise. If I'm at 1 and I go all the way up to 7, so this has a rise of 6. Well, half of 6 is 3, so 1, 2, 3. Right here is my halfway mark. So if I use my halfway marks, I can see that I have this midpoint right there. Half my rise, half my run. Okay. Excuse me. Well, it's nice that we could, on a graph do this half rise, half run, but what if I don't have a graph? Or what if I'm not interested in graphing? There has to be kind of a better way. So since we're always taking the half of it, half your rise, half your run, what you're actually doing is finding your average. So your midpoint is really just your average between your x's and your y's. So if we want to find midpoint, then you want to take your average between your x's. So you're going to add x1 plus x2 and then divide by 2. Okay, that'll give you your average between your x's. And then y1 plus y2 divided by 2 will give you your average between your y. And then this is your midpoint. You get an x coordinate and a y coordinate, which will give you your capital M, which is midpoint. Okay, so let's determine the midpoint between the following. Let's start this algebraically, and then we can look at our graph and see if we're right. So my midpoint then is, so this is x1, y1. This is x2, y2. I'm going to add my x's together. So 3 plus -9 divided by 2. And then I'm going to add my y's together. -7 plus 1 divided by 2. So 3 plus a -9 is -6. -6 divided by 2 is -3. And -7 plus 1 is -6. And -6 divided by 2 is -3. So I should have a midpoint at -3, -3. So let's take a gander at this. So 3, -7 is down here. So this would be my p-value. And then Q is at -9, 1, which is over here. Q. Now, if I draw a line between them, it's right there. So let's check. I said the midpoint was at 3, -3 up, and look at that right there. I'm saying is my midpoint. All right. Well, again, we can do what we did before to double check, in that we could make our rise over our run. This is 12. So if I divide it by 2, I get 6. So 1, 2, 3, 4, 5, 6, which is right here. That looks good. And then if I take a look at this side, this is 8 units long divided by 2, which would be 4. 1, 2, 3, 4, which is right here. And sure enough, look at that. I get this midpoint. So if we add our x's together, divide by 2, add our y's together, divide by 2, then we will definitely get our midpoint without having to do the graphing. Okay, what if I know that C is at endpoint, M is my midpoint, and I'm looking for D? So if I was given this, I would definitely try to do it through graphing. I think graphing is kind of the easiest way here. If I draw my line starting at C, going through M, and then I'm just going to extend it here, I can see that going from C to M, so going from C to M, okay, was 1, 2, 3, 4, 5 down, and 1, 2, 3 over. So if I'm trying to figure out where my other point is, that's only halfway. I need to double this. So I need to go down another 5. 1, 2, 3, 4, 5, which puts me right here. So there would be another 5. And then I need to double the 3. So this was 1, 2, 3. And now I need another 3 in order to give me 6. So my other point right here, they called it D, must be at 3 comma negative 3. So definitely by graphing, we can figure out that other endpoint. Now, what if I didn't have a graph, or my numbers were so big I didn't want to even put it on a graph? Well, then we can look at this by using points. So C right here is at negative 3 comma 7. My midpoint is at 0 comma 2. So I want to show you my midpoint, M, remember, is equal to adding my x's together and dividing by 2, and adding my y's together and dividing by 2. So in this case, I happen to know that my midpoint is at 0 comma 2 equal, I should do that, 0 comma 2 is equal to, so my first x is negative 3 plus a second x that I don't have. And y is equal to 7 plus a second y value that I don't have. Okay, now I can take each one of these, and this is, remember, is x, and this is y. So I can put them equal to their proper coordinates. So 0 is equal to negative 3 plus x2 over 2. So I'm going to multiply, remember how to solve equations, multiply both sides by 2. Well, 0 times 2 is still 0. And then if I add 3 to each side, so I get 3 is equal to x2, which is great because that's exactly what we found on our graph. Same thing now, since y is equal to 2, I can go 2 equals 7 plus y2 over 2. And I can multiply both sides by 2. 2 times 2 is 4. 7 plus y2 minus 7 minus 7. And y2 is equal to negative 3. So then this must be my point. There's my x, there's my y. Notice a little subscript 2. That means it's my second point. That was the second point that we were looking for. So that's a way that you can solve it algebraically. Whereas if you do have it on a graph, then it's just kind of doubling your side length and your rise and your run in order to get where the next point would be. Okay, just a little bit more. We're going to have to keep working on finding equations of lines. So in this case, the equation of a line passes through these 2 points. So I'm looking to find the equation of the line that passes through A and B. I know that A is at 8 comma negative 3 and B is at 5 comma 9. Okay, so equations of lines, remember, are always written as y equals mx plus b. And so the first thing I want to find is my slope, and then I want to find my y-intercept. So to find slope, I'm going to have to use my slope formula. So just a reminder of our slope formula. y2 minus y1 over x2 minus x1. Okay, so y2 would be 9, y1 would be negative 3, x2 would be 5, x1 would be 8. Well, 5 minus a negative 3 is 12. 5 minus 8 is negative 3. 12 divided by negative 3 is negative 4. Then, once I have my slope, I want to pick one of my points. It doesn't matter which one. I think I'll use B since both those numbers are positive. There's my x, there's my y. And I'm going to put all that information in for y equals mx plus b. So my y is 9. My m is negative 4. My x is 5 plus b. Negative 4 times 5 is negative 20. So I'm going to add 20 to both sides. 9 plus 20 is 29. And now I have my equation of my line. Negative 4x plus 29, which looks to be right. We have a negative slope. This line is definitely going down, and it looks like it's going to intersect somewhere way up high, which would be at plus 29. Okay, try one on your own. Feel free to pause the video here and then come back to look for solutions. All right, so let's start. Remember, equations of lines, y equals mx plus b. I'm going to start with finding m, which is my slope formula, y2 minus y1 minus x2 minus x1. So m would be y2, which is negative 6, minus 0 over 8 minus 4, which is going to give me negative 6, 8 minus 4, which is 4. I can reduce this down to a negative 3 over 2, which I think I'll do. Okay, I'm going to use that slope and one of my points. I think I like the first point. I think I'm going to use 4 comma 0. So my slope is negative 3 over 2. I'm going to use the point 4 comma 0 as my x and y. And I'm going to plug all that back into y equals mx plus b. And I'm going to get 0 is equal to negative 3 over 2 times 4 plus b. 0 is equal to negative 3 times 4, which is negative 12, divided by 2, plus b. 0 equals negative 6, plus b. Let's add 6 to both sides. 0 plus 6 is 6 equals b. Look at that. That worked out really nice, actually. So then my equation is my slope plus my y-intercept. Y equals negative 3 over 2x plus 6. Hopefully you got that one right. Okay, just a couple more on finding the equation of a line. What if I told you that the equation of a line goes through this point and is perpendicular to this line? All right, so that word perpendicular tells me that I want to take the slope out of this line. So my slope, we can do that just by investigation since this is written as y equals mx plus b. My slope here is 2, which means my perpendicular slope must be, this is a positive 2, so it's going to be negative, and then I need to flip it. So since it doesn't have a denominator, I can put it over 1, which means 1/2. Okay, so then my perpendicular slope to 2 is negative 1/2. And I have this point negative 4 comma 5, which is an x and a y. So let's put all that information back into our y equals mx plus b. 5 is equal to negative 1/2 times negative 4 plus b. 5 is equal to negative 1 times negative 4, which is a positive 4, divided by 2, plus b. 5, whoops, I'm ahead of myself here. 5 is equal to 4 divided by 2, which is 2. And then subtract 2 from each side, and b equals 3. Awesome. So there's my equation. My slope, negative 1/2 x, plus my y-intercept at 3. All right. So with perpendicular, it means you take the slope out from the line given to you, and then you write it as a negative reciprocal. Negative reciprocals means it changes signs, and then you flip it. Okay, that brings us to the end of the equation of a line and finding midpoint. Make sure that you practice this, and if you have any problems, come on back.